let's talk about area. Area is the amount of space something takes up in 2 dimensions. So let's just start talking about different ways to calculate area. So if you have a rectangle, the formula for area is the length times by the width. So for example, if the length is 6, let's just use centimeters, and the width is 3 centimeters, the area would be length times width, which equals 6 times 3. So 6 times 3, and you would get 18. And the units would be centimeters squared. Why is it centimeters squared? Because it's centimeters times centimeters. It's centimeters squared. Do not forget your units, because if you just put 18, so this would be 6 centimeters times 3 centimeters. If you just put 18, that's not the correct answer. If they don't give you units, if you're not given units, you would say units squared. But in our case, I put centimeters. So now that's the area for a rectangle. If this was a square, which means all sides are equal, the length and the width would be the same length, and it would just be, for example, 6 times 6, which would be 36, if this was a square, right? So now, let's go to the next. Let's keep talking about this. So now, let's draw a diagonal line from one corner to the other. What do you see here? Well, what you've created here is a triangle. And to be exact, it's a right angle triangle. And if you wonder, what is the area formula for area of a triangle? You may know it already, but let's back into it. If the area of a rectangle is known as length times width, and we split that rectangle basically in half by drawing a diagonal across it, what do you think the formula is for this space right here, this triangle? It would be 1/2 length times width. And when we talk about triangles, we usually use the term base times height. So you may have seen this formula, 1/2 base times height. Okay, so the base here is, we'll call it this part right here, right? The length. Okay, and so in this case, it would be 1/2 6 times the height being 3 centimeters. So this would be equal to, this would be half times 6, which is 3, times 3 is 9 centimeters squared. Okay, if you notice, it's half the 6 times 3, which is 18. Or you could just do 6 times 3, 18, times by a half, right? That's 8. Excuse me, I'm sorry, 9. Right, 9. This way you show your work. Okay, so now, the key to that triangle with height is that the height of a triangle is the distance from the base perpendicularly to the opposite angle, right? The opposite corner from the base. Okay, so in this case, it's a right angle triangle. Therefore, that the side of the triangle here, the adjacent side to the base, adjacent means next to, side of the base, is the same as the height. Okay, so imagine you were standing here holding a pole vertically. Once it lined up with the opposite corner, that would be where the height was. If you moved over here instead and stood over here, this is not the height, right? This right here is not the height, right? If you're standing here. The height is where it meets the opposite corner and it's a right angle. You're holding it straight up and down. All right, so we'll talk about that more in a second here. So the area of a rectangle is length times width. The area of a triangle is 1/2 length times width, or 1/2 base times height. And remember, the height is the perpendicular height. So let's go into that a little more. The key thing is knowing the formula, right? So now triangles aren't always right angle triangles. Triangles can be in many shapes. It can be like this, like an isosceles triangle, where these two sides are the same. It could be an equilateral triangle, say, where all three sides are the same. And it could also be different types of triangles, different shapes. They're not all shaped like this, which you typically see triangle. The triangle could be shaped like this, right? Where in this case, this is the base, but where's the height? Okay, the height isn't this. The height is always perpendicular to the base, okay? So just imagine the line continued. So you look to the opposite corner, right? So there's the opposite corner to the base, the opposite corner. So the height is, imagine if you were up here and you dropped a pebble and it went straight down. That's the height, right? Or if you were standing here holding a stick till it hit that perpendicular peak, that peak, and the stick was perpendicular to the ground, meaning you're always holding it 90 degrees to the ground. That's the height. The height isn't here to here. The height is from the same level as the base, perpendicular to the opposite angle or corner. All right, so that is how you calculate it. So then if, for example, say the triangle is like this and like this, sorry, it doesn't look great, but the height again is this thing from this corner here to here. The height may be like this. All right, and when you get a problem, they should give you the height. They'll show you where the height is, or they may try to trick you and say, say this is 5 and this is 4 and this is 3 and this is whatever. I'm just making up numbers 2. And then you have to try to figure that out, what values do you use? So in this case, you'd use the base of the triangle is 3, the height of the triangle is 4. So it'd be 3 times 4, 1/2, base times height. So that'd be 12 and 6. That'd be 6 units, because I can give myself units squared. If it was centimeters, it'd be centimeters squared. All right, so that's just a quick overview of what an area is for a rectangle and for a triangle. So hopefully, if you've had trouble memorizing formulas, maybe this will help you remember is that in a rectangle, half a rectangle is a triangle. The area of a rectangle is, again, length times width. So if a triangle is half a rectangle, that means the formula for a triangle is half length times width, otherwise known as half base times height. Okay, you can use a dot or an X to represent multiplication. And again, be careful what you choose for height. This is just showing you how this formula is derived. But again, in a rectangle, the height happens to be the same as the one side of the triangle. But in some cases, again, the height is not this side here. The height is, in fact, the perpendicular distance from the base level to the opposite angle or corner of the triangle. All right, hopefully that's helpful. We'll keep talking about area of other shapes. we get into area of the circle, which, you know, for future reference, area of a circle is pi r squared. Okay, pi r squared. And for next video, we'll talk about this pi r squared so you get more familiar with it, and maybe it'll help you understand how to remember pi r squared, because remember pi r squared is 3.14 r squared. And so next video, we're going to talk about that formula, and maybe it'll help you remember that formula for a circle. And then once we've done that, then we can start talking about volumes of cylinders, of prisms, of other shapes, cones, etc. All right. Math is fun, and it's all around us.